On this video, we're going to talk about metals, metalloids, and nonmetals. Metals are found on the left of the periodic table. Metalloids are found on the right of the periodic table with nonmetals. So metalloids are found between metals and nonmetals. What are the properties of metals? Metals are solid at room temperature, except for mercury, which is a liquid. So room temperature is 25 degrees unless you are told. They have high melting points. They have a shiny metallic appearance. They are non-transparent, so you cannot see through them. They're strong. They're malleable and ductile and can be drawn into wires, strands. I hope you still do remember these properties of materials, because I told you guys that you need to know the properties of materials for exam purposes. They are good conductors of heat, and they are good conductors of electricity. Where do we use metals? Metals are used in saucepans because they are good conductors of heat. So you want your saucepan to be able to conduct heat to your food so that your food can be cooked. They are used in electric wires because they are good conductors of electricity. They are used in jewelry because they have a shiny appearance. They are used in steel beams because they're strong. And they are found on the left side of the periodic table. I already told you that. Nonmetals are also solids at room temperature, except for bromine, which is liquid. The molecular solids have very low boiling and melting points, but network solids, such as diamond and graphite, have very high boiling and melting points. They have a dull appearance and many different colors. They have low densities. Remember, density is mass divided by volume. They usually break easily. So I hope you still remember which property of material is that. It is brightness. They are poor conductors of heat and electricity, except for graphite and diamond. Where are they used? They are often used as insulators for safety purposes. So your plastic coating around your conducting wires, they are insulators because you don't want to be electrocuted when you are carrying your wire. Your wire inside does conduct electricity, but the coating outside is an insulator so that it doesn't conduct electricity to you, so that you don't get electrocuted. They are found on the right side of the periodic table. Metalloids, also known as semi-metals, they look like metals but could be dull. So the properties of metalloids, as we go through them, you're going to see that they're between the properties of metals and the properties of non-metals. So they are less dense and they're usually brittle. They are semiconductors, meaning that they conduct heat and electricity better than non-metals, but not as good as metals. And they conduct electricity better when they are heated, which makes them different from metals, because metals do not conduct electricity better when they're heated. They actually are bad conductors in high temperatures. They are used in electronics industry, like your microchips in computers and calculators. They are found in either side of the step that separates the metals from the non-metals. So you saw on that diagram that I showed you on the first slide of this video that there's a step that separates metals and non-metals. So they are found on either side of those steps. Now we're going to look at electrical conductors, semiconductors, and insulators. We're going to start with electrical conductors. So an electrical conductor allows an electric current to pass through it easily by offering little resistance to the flow of a current. So for example, in your wires, you have very little resistance to the flow of current because you want your current to flow through your wire for electricity to be connected. Your examples are silver, copper, aluminium, steel, lead, etc. So you know that most wires are made of copper, because maybe you've heard of copper theft. They steal the copper wires for electricity, and they're very expensive. Non-metals like graphite, which is made of carbon, so they also conduct electricity. Where are these used? Again, they're used in electric conducting wire, long distance power cables, electrodes in electrolytic cells in batteries, because that is where you want your current to flow and to conduct. So semiconductors. A semiconductor that is made from metalloids is a very poor conductor of heat when it's cold, because remember we said metalloids, they conduct electricity better when they are heated. Your examples are silicon and germanium. Where are they used? They are used in transistors, electronic components in computers, solar cells, LCD screens, etc., and in other electronic devices. Non-conductors or insulators. These do not allow the flow of electric current, and therefore they have a high electric resistance. So they are the opposite of conductors. Your examples are fiberglass, plastic, ceramics, diamond, like carbon. So we understand why now our conducting wires are coated in plastic, because plastic is an insulator. So for us not to be electrocuted by electricity, we need a coating that is not metal that can conduct electricity or heat. Thermal conductors. So a hot object has a high internal energy, and if it comes into contact with a cold object, thermal energy gets transferred from the hot object to the cold object. Good thermal conductors are those that allow heat to pass through easily, like copper and aluminium. And we see this used in our saucepans and most pots, because we want, again, our saucepans to be able to transfer heat to our food so that it can be cooked. Non-conductors are those that do not allow heat to pass through, like wool, rubber, plastic, fur, hair, wool, and feathers. So these are used in handles of saucepans, which makes sense because you don't want to be cooking while getting burnt by the handles of your saucepans. And also we wear fur and wool, and animals have fur and hair so that their bodies could keep warm. So these fur and hair and wool and feathers, they prevent heat from passing through and escaping so that we can keep our bodies warm and animals' bodies warm. So that is it on this video. On the next video, we will talk about magnetic substances.